Welcome to this 3 steps to sketch on function transformations. In this video, we are going to look at the transformation of a reciprocal function. So that's our parent function, y equals 1 over x. So we'll be looking at y equals 2 over x plus 1, and we'll do this using our table method. All right, there's our reminder of our equation. And here's our setup. So we have our 3 steps to sketch outline and our table and grid. So remember, our parent function is y equals 1 over x. And this is the one that we nickname butterfly. So it has the curves in the first and third quadrant and the asymptotes on our axes. All right, so now that we have reminded ourselves of what we're starting with, let's look at the transformations. And so to do this, we may want to rewrite the equation because the 2 could be confusing. So instead of saying 2 over x, let's rewrite this as 2 times 1 over x. And that makes it very clear that that 2 is causing a vertical transformation, a vertical stretch on the parent function. And then, of course, we still have that plus 1. All right, so we have rewritten this now. We can deal with it a little bit more clearly. And we can also see there are no horizontal transformations for this particular equation. So our x's are not impacted at all. They're the same as the parent function. All right, so we have 2 vertical transformations. These affect the y coordinates only, and we need to apply them in PEMDAS order. So we know that means multiplication comes before addition. All right, so this 2 times will happen before this plus 1. All right, so if we see 2 times, we know that means our y's are being multiplied by 2, or we're stretching out vertically. So that's a stretch by a factor of 2 times our y's. Okay, and then we'll finish up with the addition. That moves us up 1, or y, all the y's plus 1. Okay. So now let's go on to step 2. We'll put our points into our table and then we'll transform them. Okay, we really only have 2 points here that are parent points, so think back. Let's do a quick sketch. We know the point 1, 1 is a good one to set the curve in the first quadrant, and -1, -1 is a good point to set it in the third quadrant. Okay. So if we transform those points, we should be good. We'll also take a look at where the asymptotes should fall and what kind of transformation will affect the asymptotes. All right, so now let's go ahead and apply our transformations. Okay, we know our x's are the same as the parent function, and our y's are what are transformed. So first, we'll multiply our y's by 2. So 2 and -2. And then we just need to add 1, which shifts our graph up 1. Okay, so now we are ready to move to step 3, plot these points and sketch the graph. And remember, it's really easy to find your final points. They're just in your outermost columns on your table. And in this case, your x column, the original one, is considered your outermost column for x. Here and here. So we'll first plot the point 1, 3, and we'll next plot the point -1, -1. Okay, so it should be pretty easy to see that our vertical asymptote, the one that's on the y-axis or at x equals 0, didn't move. We didn't have any sort of horizontal transformation, and a horizontal shift is really the only thing that's going to get that moving. And then our horizontal asymptote, we see was impacted by our vertical shift. So the stretch didn't do anything. Multiplying 0 by 2 doesn't do anything, but moving up 1 also moves that horizontal asymptote. And you see it stays between our 2 major points. Okay, and so we are ready to sketch in our final graph. Those asymptotes guide the way, and we have our graph of y equals 2 over x plus 1 using our table method.